Hi class, this is Rayhan Biju, and today I'm going to talk to you about single sign-on authentication, otherwise known as SSO authentication. Before I explain what SSO authentication is, let me show you an example of how it works. Imagine you have an apartment key. This apartment key allows you to access your locked gym, your locked mailbox, your locked laundry room. You get the idea. This master key allows you to unlock anything you give it permission to. Now, you don't have to go around carrying multiple keys and risk losing any one of them as long as you have your one master key. Think about the endless possibilities with having just one key to unlock anything you want. In this example, SSO authentication acts as the master key. Your username and password are stored in this master key, and each website you visit is this lock. Once your username and password are verified by the lock, your access is granted. In this way, you won't have to remember multiple usernames or passwords when accessing different websites in the digital world. Now let's explore how this process actually works. In this diagram, you can see how the SSO authentication process works. Each of these steps represent lots of interactions that happen at the system, networking, and web application level. Initially, as a user, you only have your passport in your hand. This passport contains your username and password. Together with your passport, you attempt to access a website that's restricted by a firewall, accessible to only users within a certain school system. Fortunately, you belong to that school system. Before the website proceeds in logging you into the system, it first checks if your passport is up to date. An access token is the key in SSO authentication service, like the passport checker, generates when your credentials are a match to what's expected. All access tokens contain the expiration date. This process occurs here. If your access token is expired, the SSO server will send a response to get you redirected and type your username and password in a secure web application window like this. Once you type in your credentials, your information will get verified by the SSO authentication server, and a new access token will get generated with a new expiration timestamp. This makes this process extremely abstract and simple for websites that want to use SSO functionality because all the logic is done from the SSO web server side, and all websites have to do is require an access token from the HTTP request header. A more formal name for the SSO server is the authentication server. Now we're going to talk about the different types of authentication servers. There are different types of authentication servers, more than what I'm showing here. The first authentication server is SAML. SAML stands for Security Assertion Markup Language, and what distinguishes it from the rest is that it uses XML to communicate information across different web mediums. Once a request is received from a service provider, also known as a website, the service attempts to authenticate the user. If the user is authenticated through making a digital XML-based document verifying the user's successful authentications, the authentication system grants the user access to the destined resource and is logged in. The next authentication server I will discuss is OpenID Connect. What makes this software so interesting is that it works across mobile and web domains. The software is built on OAuth 2.0, offering a new sophisticated way to manage and use access tokens through JWTs. These tokens contained the same type of information that existed in the previous access tokens that I discussed. The flow of the system works in the same way that OAuth works, by a user requesting an ID token through verifying credentials on an authorization server. Finally, the last authentication server I will talk about is OAuth. The server allows users to access third-party or external websites without password sharing, and often through a sign-on to social media accounts. This occurs through an exchange between the client and a resource server, which is the website you wish to log on to. This type of SSO authentication server is used heavily in social media integrations. Let's talk about session management as SSO. What even is session management, you may ask? It's a centralized control or management indicating whether a user is authenticated or not. This can be managed by browser-stored data called cookies. These cookies are typically set by authorization servers and are meant to be stored until a cookie meets its expiry date. Cookies are an establishment of trust that can be set between the SSO server and the websites themselves. Within session management, sessions typically expire, and this is determined by the access tokens generated by the server. Once its expiration date passes, the SSO server will require the user to re-authenticate. But session management in SSO is not just about keeping users logged in. It's also about securely managing their logout process. When a user decides to log out, the SSO server needs to ensure that the session is terminated, not just on the primary service the user is interacting with, but across all services accessed via the SSO mechanism. Considering this, let's pause and think about the steps that need to be completed for an SSO server if the user wants to log out of the system. I'll give you 10 seconds to think about this, or you can pause the video and come back if you need to. You may have thought this process would be complex, but actually, you can imagine if you were a server and what steps you would have to complete to log out users, making this system quite simple and abstract. This is an abstracted to-do list a server would have to make if it were to log out a user. First, it would invalidate the original token it provided in the current session. Then, it will remove any associated cookies in the current session. After, it would send a message to other websites linked to it, making it known that the user wants to log out of the session, which would prompt those websites to log the user out. Finally, the SSO server would redirect the user to a specific web confirmation page addressing the user's logout request. Now that you have a clear understanding of how SSO authentication works, both behind the scenes and at the service level, with its possible integrations, it's important to understand how security is built into SSO and its pitfalls. First, it offers a centralized sign-on service, making users less likely to forget their passwords. It reduces the hassle of constantly signing in and out of accounts and mitigates potential vulnerabilities. Then, with the addition of multi-factor or through two-factor authentication, it makes authenticating with SSO ever so easier and secure. In the Virginia Tech ecosystem, for example, the usage of Duo Mobile would be a two-factor authentication system. Duo was usually connected to an SSO server or gateway like that of Virginia Tech's, allowing a further layer of security with SSO applications. Two-factor or multi-factor authentication systems allow one or more verification and physical touch belonging to a trusted device of the user. Finally, the last of many security extensions involved with SSO authentication is its use of encryption, especially when using the latest techniques to encrypt sessions and access tokens, making it hard for hackers to crack. Finally, we'll talk about the pitfalls with SSO-based authentication systems. One of the biggest pitfalls is the single point of failure. If the SSO server is breached, linked applications to the SSO server are all at risk. However, this does not have to even be the case if the server is breached. If the server also has a downtime for maintenance, for example, this will affect linked applications. Another pitfall is the SSO server can give unauthorized access to a website if the credentials are breached, as if providing a Trojan horse of sorts to websites following unauthorized credential usage. Next, if an SSO application or API is not configured properly, it can lead to breaches and data leaks. So what should you take away from this presentation? Authentication is powerful, sophisticated, and very easy to use. With so many libraries and frameworks out there, all the hard work for creating the services is done for you. So it's just a matter of configuring the necessary endpoints. Its portability is what makes it easily integrable in any software domain. Furthermore, it encapsulates a great user experience. A user only has to worry about entering their credentials, and the service handles the redirections for the user. SSO is also secure. By modern advancements to tiered security, such as two-factor and multi-factor authentications, it allows SSO to be ever so hard to crack, coupled with it having lots of regulations with data protection and safety. With the technology being so robust, it can handle what the future holds in the space of web application and token security. Below is a great course for understanding SSO authentication and the processes and systems behind it, including what IAM or Identity and Access Management is by working with Okta, a leading company in that space. I highly recommend you guys to check it out. Thank you for watching. And this is just a bibliography of all the references I used for all the pictures and content on this presentation. Thank you again.